Just to show you real quick, just to remind you guys, negative x squared plus 3x plus 4. And if I graph this thing, I can ask the calculator, go to calculate up here, calculate. So please, calculator, give me the integral from 0 to 3, 16.5, so that makes 16.21875. Sounds like a good approximation. We only use 4 rectangles, so that's pretty damn close for only 4 rectangles. Pretty low resolution. I like it. And when you do this stuff, you don't need to have fractions beyond. You just use all calculator. I really hate that I did that, but it happened. It's just too bad. So let me catch up with you. Does everything here make sense? I mean, this is what you're wanting to evaluate. So you need to know what delta x is. You need to know what xi is. And all you do to get xi is you start with the first number and you add the width times I. Because how do you get to the second one? You would add 3 over n twice. So that's why the little I would be a 2 then. That's how you get to the second one. You add 2 3 over n's. So it's like the step size from one to the next. So that's why that is how you get xi. 0 as a starting point is awesome, because then xi will just be your width times I, because you're adding it to 0 to start with. Much hope. So I mean, if your delta x was 2 over n and your a was 3, then your xi will be, how do you get to the next one? You would take 3 and you would add 1 of these. How would you get to the next one? You would take 3 and add 2 of these. So how would I get to the ith one? I would take 3 and add I of these. Right? That's how you get what xi is. You take the first number plus I times the width, because that's how many widths you're going to add to get to that xi piece. And then f evaluated at xi, just take what you got and plug it in. Slow bang. And now you can piece this sucker together to the limit n goes to infinity of negative 3i over n squared plus 3 times 3i over n minus 4, all times 3 over n. Becoming 3 over n. There you go. Is that cool? There's your f of xi, there's your delta x. Where did I put my sum? I lost my sum. Shoot. So the limit of the sum, I'm going to break each of these up a little bit. So this piece here is going to be, let me try to do several things. So if I square this, I'll get negative 9 I squared over n squared. Let me just do this one step at a time. Plus 9i over n minus 4, multiplied by 3 over n. Bunch of algebra here. Limit n goes to infinity. Now I can break my sum up and bring the 3 over n in. So this will be negative 27i squared over n cubed plus the sum. See what I'm doing? I'm breaking the sum up and I'm bringing the 3 over n in. Plus 27i over n squared minus 12 over n. That's right, we did that one. How's that jiving so far? Is that? It matches perfectly with mine because I'm copying yours down. But see, the manipulations we have to do, not that major. This is all algebra level stuff so far. But now when I take all the non-I stuff out of the way, I have to know how to rewrite the sum that's left. So I get negative 27 over n cubed. Sum of I squared. What's the sum of I squared? this crazy thing, right? I'll give you these. I don't know if I told you that. I'll give you these. I don't have this one memorized. I'm never going to make you memorize something I don't have memorized myself. It's kind of like the opposite of a gym teacher. Some of them anyway. And so it's n times n plus 1 times 2n plus 1 all over 6. I mean, it's only obvious. No. Plus, take out 27 over n squared. And the sum of I is going to be n times n plus 1. That's the little urban legend one. Over 2. Minus, take out the 12 over n, and you're left with n. So is everybody cool? That's just going to be minus 12. The sum of 1 is going to be n. And the n's cancel. That's what I mean about the degrees match between the n's that are there and the n's you bring in when you rewrite the sum of the I pieces. What's this limit here going to be? They're going to have the same degree, but the coefficient, of course, is going to be 2 to 1. So 2 over 6 is 3, goes into 27. I get negative 9. So recall that this limit is 2. 2 over 6 is 1/3, goes into 27 9 times. And then here, this limit, of course, is going to be 1, because they have the same power, 1 coefficients. So 27 over 2 minus 12. So what do you guys get at the end? So negative 21 plus, so negative 42, so that would be negative 7.5? Yeah. Now real quick, see how the minus 4, it would have been, if it was plus 4, this would have been plus 12. So that would have been, yeah, which is exactly what it's supposed to be, right? So that was a quick fix at the end. I hate that I put a minus 4 there, but you guys see how that minus 4 just in the process just contributes to the minus 12. If it was a plus 4, that would have been a plus 12. And sure enough, if you add 12 instead of subtract 12, you get 16.5, which is the exact right answer. All right. And then this one is the one we just learned, the easy-ass way to do it, right? Thank God. What's the antiderivative of negative x squared? I like it. 3x will become good. And then 4 becomes 4x. And I want to go from 0 to 3. It's always awesome when there's a 0 input. Except when you have e to the x stuff. People get a little too 0 happy. And like, everything's 0. No, you got to be careful. Here's polynomial. I don't even have to put 0 in. Yeah, I just got to put 3 in. So I get negative 3 cubed over 3 is negative 3 squared is negative 9. Plus 27 over 2. This is looking very familiar. Right? And then plus 12 because it's a plus 4. You see that shit? You see that shit? You see this? And then I get 16.5 like it's supposed to be. And that's the exact right answer. Real quick, let me see. Yes. Haha. You guys have been let out early too much. Now watch this. And you're like, no, Jeff. Let's keep doing that. I'm going to make you suffer through this one thing. Well, yeah. Sorry. You guys would disagree with that immediately. You make us suffer through all kinds of stuff. You're never going to have to do this on your own. So you might be like, I don't want to watch this then. I can't force you to look this way. But I want to take this function we just did. Just real, this is going to be quicker than you would think it would be. Function we're working with, the actual function, negative x squared plus 3x plus 4. And I'm gonna do the whole process, but I'm gonna go from 0 to x, not 0 to 3. Because I'm crazy. So delta x would be x over n. Is that decent? You guys get what I'm doing? Instead of 0 to 3, I'm going 0 to x. If I do this whole process, the answer has to be the antiderivative if everything we talked about today is true. If it doesn't come out that way, we can all go home and forget about calculus and you all get A's. And you're like, come on, Jeff, make a mistake. Come on, it's too bad. I already worked it out. Ha. So, no, I don't blame you, though. You're like, come on, dude, just make a mistake. And here's where things get a little bit weird. Hopefully you guys can handle this, but xi would be x over n times I. So this is x sub I is x times I over n, just like we had 3i over n, right? Okay. And then, so f of xi, now just plug an xi over n in. Square plus 3 xi over n minus 4. Is it minus 4? Plus 4, thank you. All right, you go away. That's where you guys are going to be like, yeah, Jeff, is minus 4, sounds good. All right. So now I want to evaluate limit as n goes to infinity of the summation I equals 1 to n of this business. Let me go ahead and do this. Become a 3. All times x over n, the width. That's the width, right? That's delta x. That's f of xi. There's the other stuff. That's your form filled in. Let me try to truncate this a little bit. So this would be negative x cubed over n cubed. Is that cool? Man, Jeff, you can write a 3. Someday I'll be able to do that. I'm still working on it. Sum I square plus 3x squared over n squared. Sum I plus 4 over n, 4x over n, sum 1. Oh, shit, Jeff. I lost it at the end there. All right, so 4x over n, that can all come out, and I'm left with a 1 inside. So this will be negative x cubed over n cubed times, this is cool, just watch. You don't have to write all this stuff down. If you're madly writing, stop. This was, let me see if I remember. I don't remember. I'm never going to remember that. N times n plus 1 times 2n plus 1 over 6. That's what that guy is. Plus 3x squared over n squared. I know that one. N times n plus 1 over 2. Plus 4x over n times n. That's what that guy is. It's just n. Plop. So I get this limit, and left my limit off. This limit is 2 again. 2 over 6 is 1/3. So I get negative 1/3 x cubed. You guys should be seeing it by now. This is going to be, this goes to 1. So I get 3/2 x squared. And then over here I get 4x. Which, of course, is the exact same thing. I don't know if you really see what's important here. How do we figure out that this is the antiderivative? All that weird shit and the big ass F and all that shit, right? I can't prove it in general, but I can do it for individual situations and say, look, the answer did come out to be, bless you, the antiderivative of what I started with. I can't do a proof this way, though. Because maybe I'm lucky with every function I do, I just get lucky that it works. And I haven't picked the functions that don't. Believe it or not, that can't be officially a proof. But hopefully some of you guys realize that's the method. That's how you do it. That's how you get the exact answer. And the exact answer comes out to be the frickin' antiderivative. That kicks ass. This is area shit. And what do I get? Antiderivative. Connection. Okay, hopeful is me. Okay. Now these, when I say f-talk, I'm going to say two or, obviously f-talk 1 would involve taking a derivative of an integral. These are all f-talk 2. So, I don't know if you guys got to these. These should have been the easiest ones on the page, along with this one. What's the integral of 3x squared? And the integral of 1? And then I just got to plug those in. So here you get 27 plus 3 minus negative 1 minus 1. You guys, so you get 30 plus 2, you get 32. That's amazing. You can always check that on your calculator. Is everybody cool with that? That's awesome. You gotta love that shit. What's this become? Tangent. I love it. Because you gotta think backwards. What do I think the derivative of to get this? And now I gotta go from 0 to pi over 4. What's tangent pi over 4? 1. What's tangent of 0? 0. Sweet. Kicking the ass in. And then finally, this guy looks horrendous, but what's the integral of e to the 3? What's the antiderivative? It can't be this, right?
1/3.
Good. So when you plug a natural log of 3 in, let me see if you guys can do it. Let's see. E to the 3 ln 3 minus 1/3 e to the 3 ln 2. Well, how the hell do you do this? You circle this shit? No. You're better than that. What can I do with that 3? I'll tell you what you can do with that 3. No. What can I do with that 3? Bring it back up. It's the power that came down. You bring it back up. The e natural log cancels. You get 1/3 of 27. Right, that goes back up here. 3 cubed 27 divided by 3 is 9. Minus. Bring it back up. The e to natural log cancels. 2 cubed is 8. Minus 8/3. Oops. Equals 19/3. Okay, cool. I like it. I can't believe I snuck in there that thing. That's pretty good. That's pretty quick, though. Let me leave that up there. This kind of thing here is going to basically rule our lives for the next part of the class. And it bleeds over to the next level. Like I said, Math 280, you have to take Calc 2. You just pick up right where we leave off. You just keep learning more and more ways to integrate. The first thing we're going to learn, the way to integrate, is related to integration's answer to chain rule. It's called U sub. And a quick thing about U sub before you, just because it's in our future, and then I'll let you guys go. Just to remind you of the places that U sub showed up before. Oh shit, I thought that was somebody tapping a song. Now. Let's turn that dude off.
Might be someone.
It's a tap dancing raccoon. Yeah, that's good. Alright. Have to call that one in. Before it blows up. Alright. Alright, so do you see this thing? I mean, the first thing a lot of students do is they just FOIL this thing out and then go slowly insane. Or quickly, depending how close they were to begin with. But U sub can be used here. If you let U equal this, then you get U squared minus 6U minus 40. That looks a hell of a lot better. So what U sub does, almost any time and anywhere it's used, is it focuses our attention on the form of something, and then we can bring back in the ugly details after we work with that form. So it's the same thing with integration. The same exact thing is going to happen. And so, real quick, this would be U minus 10, U plus 4, so then you get 5 minus 2x cubed minus 10, who cares? All right, and you can simplify that. You guys with me? You plug back in what the U was. Just to remind you of, maybe a teacher showed you this, maybe not, but this is the first place you see U sub, is this kind of problem. So what we're going to do, just to give you a real quick example, is if I had integral, let's see, how do I, yeah, let's do this. Integral of 2x cosine of x squared. So let me ask you something. Do you see how the chain rule piece is in there. So this should be able to be done. If I let u equal the piece that's giving me trouble in the first place, which is the x squared. So let u equal x squared. What's du then? 2x dx. Remember the differentials we did? So look what this has done. I mean, now just look at that. Does that make sense? U is x squared, because that's the piece that's giving me trouble. Its derivative is in there too, which tells me that it's just a chain rule that I can undo now. What does this interval look like now? What's 2x dx? Du. And what's cosine x squared is cosine u. And what's the interval of cosine? Sine. It's hard to change those gears. I know what you mean. But think sine, and then to check yourself, if you put this, go, wait a minute, sine is cosine. No, that's okay. So it's sine u plus c, but what was u? X squared, yeah. So as long as you end with the variable you started with, let me make sure it's not a negative, you're good. The middle was just me making it look better. So that u substitution is the first thing we learned. It's actually the most not the most powerful thing, but it is the most used thing. It's used in other forms as a first step and so forth. So we have to focus on how can I tell. This was a really easy example. But then how can I tell if it's a problem that u sub will work on, and how can I tell what to let u equal? That's not always an easy question to answer, but this is the idea behind it. Okay, I think that's plenty for today. My God. Oh. I do want to have a quiz. I was thinking Wednesday on 4.9 through 4.9 through 5.3. And I am very much thinking about, I'm trying to find somebody to cover Thursday's class, which is a review day, because I have to be out at a conference. I haven't gotten somebody yet. So if I can't find somebody, I'm thinking about moving the test to by a day and have the review on Monday. It's not a set thing yet, but I'll let you know tomorrow. If I haven't heard back from somebody, I'm just going to have to do that. All right? And you guys are like, sounds good to me. All right. Okay, that's enough.